All right, this is question number 10 from the review. We're going to do this rational inequality. So again, the first thing I would do is write this out in factored form. I'm okay with the denominator being x minus 2, the numerator x and x. My signs have to be the same. They both have to be positive. The only numbers that multiply to 3 are 3 and 1. And all of this, I want to know when it's less than 0. So a couple of things I need to graph. I need the x-intercepts. And again, I'm thinking about what would produce a 0 in the numerator, right there and right there. And my answer would be negative 3 would produce a 0 in that first set of parentheses. And negative 1 would produce a 0 in that second set of parentheses. So here are my x-intercepts on the graph. Next thing I would do is find the y-intercept. And that's if I were to plug in 0 as an x value, what y would I get out? I like to look back at my original. That would be 0, 0, 0. And all of this would turn into 3 over negative 2. So negative 3 halves. And that is about right there. I'll go ahead and do the vertical asymptote. And that's what would produce a 0 in the denominator. And it looks like 2 would produce a 0 there. So I'm going to say x equals 2. And again, we're not plugging in 2. This is the equation for the line, this dashed line that my math cannot cross because I cannot have zeros in the denominator. All right, I also noticed that this is a top bigger scenario, which means I'm going to have slant asymptote. And so I'm going to do my polynomial long division over here. Actually, I'll do it on this side of the board. So x minus 2 goes here. And then I get x squared plus 4x plus 3. And again, I'm trying to multiply this first term to turn it into x squared. And I need to multiply it by x. And it's a lot like distributing. Each of these need to be multiplied by x. And I would get x squared minus 2x. I put a line underneath it. And this is a very important step. I have to subtract this entire row. So change your signs. This would go away. I would get 6x plus 3. And again, what do I need to multiply that x by so it turns into 6x? And the answer is plus 6. I would get 6x minus 12. Put a line underneath it. Change both sides. But I really don't care about this last number. This is my remainder. It does nothing for me. What I want is this. So my slant asymptote is y equals x plus 6. So there's my y-intercept at 6. And again, there's no grid marks here, so it's hard to like rise and run. But I could always go backwards. And if it has a slope of 1 over 1, it should cross here at negative 6 as well. And I'll go ahead and put a slant asymptote through that. Goes out that way. This goes down this way. And I've already typed this into my calculator so we can see what it looks like. And I've changed my window to look like the window in the graph. And you get something that looks like that. And I can also check my slant asymptote. I'll type it into y2, put x plus 6, and it looks perfect. I'll pull that off from my notes down here, close that out, sketch my graph. So we should have something that comes up here, crosses through these points I made. And then I have something similar over here. And now I will highlight the parts I care about. All of this is less than. Oh, I should emphasize that these are open circles here because I can't actually equal 0. So all of this stuff is less than in blue. It would be less than right here. And all of this stuff would be greater than that little sliver here and all of this. And you'll notice I care about the stuff that is in blue because all of that math it says is less than or equal to 0. So my answer would go, my x values could go to the left forever, negative infinity. And they would go right up to negative 3, but I don't actually get to touch that point, so it's an open circle. And then I would pick back up at negative 1, open circle, so I have to have an open bracket. And then I would get really close, head in this direction, to this blue line, but I don't ever get to touch that as well. And so that blue line is occurring at 2, open, and this is my final solution.